Hello, my name is Jacquie Maly, and I'm recording this from the Aerospace lab at Windward Community College on the island of Oahu. Today I'm going to talk a little bit about the vocabulary that we use in science. There are some words that we toss around pretty freely, and maybe we can tie down at least my definitions for those words. And those words are things like fact, and law, and hypotheses, and theory, and data. So we're going to look at those, and then we are going to do an experiment to see how those laws and those words tie together in science. Okay, let's take the word fact. Now, I don't know what you mean by fact, but a general kind of thing that most people agree is a fact is a single verifiable observation. So, for example, if you see something drop, you saw it, other people can verify it, it's a single verifiable observation. It doesn't mean it's always true, like we usually pound our fist and say, well, it's a fact that something is, especially if we want to win an argument with somebody. It's simply a single piece of data is what that really is. And a second word that we sometimes come up with is law. And law sounds really impressive, like it is the final answer for something. But let me give you an example. Actually, a law, in my way of thinking, is a generalization of those observations that you have made. And so, for example, let's imagine that every day at 5 o'clock, you and your older brother go out and play catch. Do you expect that to continue on? The next day when you come home, are you going to show up at 5 o'clock and expect that he is going to be there and you're going to play catch? And after you've done that a whole flock of times, you really get convinced that's always going to happen. And then one day you come home and he's not there at 5 o'clock. And you ask your mother what is it all about, and she says, well, your brother went to college today. Now, that means you're going to have to change your laws. So laws are not eternal. They get changed when you get new information. Okay? So we have talked about data, we have talked about facts, we have talked about laws, and we need to talk about a hypothesis. Well, maybe in your textbooks you see the phrase hypothesis is an educated guess. And I really have always been unhappy with that because you really can't do anything with that. My definition for a hypothesis is it is a prediction based on what you have already seen and thought about, basically. And when you make a prediction, then you have a chance to do an experiment and see if your prediction is validated. And so that's what we're going to talk about today specifically and give examples in a more scientific way beyond your brother and you playing catch. This represents one of a flock of laws that was generated by Sir Isaac Newton. And there are several of his laws of motion, but the one that we're going to talk about today, he said, for every action, there is an equal and opposite reaction. Now, realize that means a whole flock of times we have taken a look at it and we kind of believe that's kind of the way things are going to go. But let's see if that's the case. I'm going to give you one observation and you can think about it. I'm going to pull this one ball sphere back and we note that one sphere comes out on the other side. That's one piece of data. Now, if I pull two spheres back, two spheres go out on the other side. Equal and opposite reaction. And if I pull three spheres back, equal and opposite reaction. Now, what will happen if I pull four spheres back? If I pull four spheres back and let them go, well, I'm not going to do that for a second. I'm going to ask you to make a hypothesis, a prediction. If I'm going to pull four spheres back, what do you think will happen for the equal and opposite reaction? So all of you got your hypotheses in mind? Take a second, figure out what you saw, think about what's going to happen. Okay, you ready? Now we're going to do the experiment. You have a hypothesis and we're going to test it. I'm pulling four spheres back. Was that what you predicted? Well, it may or may not have been. When you do an experiment, they don't always get the answer that you wanted, and that's okay because you learn something from that also. Okay, to summarize, we have talked about facts, we've talked about laws, we've talked about theories and data and pretty much hypotheses, but we haven't really talked about theories. And a theory, the way I think about a theory is an explanation of what we have observed. And I'm going to let you explore or do some research on those theories that have to do with Newton's laws. I think you might find that very interesting. I hope you continue making observations and enjoying science. Thank you very much for your attention.